Welcome. This lesson is over rates, unit rates, and proportion. With that, we'll be able to make prediction, educated guesses, and then we'll be able to graph. Are these rates equivalent? If not, fix it up. Predict how many tickets for $8. So for $2, you can get 6 numbered tickets. For $5, you can get 15 tickets. For $7, you can get 40 tickets. Let's find the relationship. Would you like to do the relationship between them or within, from side to side or up and down? Well, 2 does not go into 5. So you know what? I'm probably going to do it this way. The relationship from 2 to 6 is times 3. The relationship from 5 to 15 is times 3. Ooh, from 7 to... That's not times 3. This should be $21. Another way you could have done it is, could you have found the unit cost or unit price? $1, you can get 3 tickets. Or another way, what if you just want 1 ticket? How much would that cost you? 33 cents. So for every, it's like 3 for $1 if you think about it. For every ticket is 33 cents. So if you had to make a prediction for $8, you can get 24 tickets. So each table is going to be getting a carton of eggs. $3 for 12 eggs. Definitely not Costco and Aldi prices. So here's a table. Determine the unit cost for the unit rate for the cost of 1 egg and use the unit rate to complete the table for 1 through 11 eggs. So I'm going to make a table right here. You don't have to, you don't need to. So the cost is $3 for the number of eggs, 12. But I need to find the cost of 1 egg. Many ways you can do it. Pick one. Do you see a relationship from side to side or up and down? If you do it up and down, how do you turn a 12 to a 3? Divide by 4, which is really times 1/4, because remember, divide by 4 is really multiplying by its reciprocal, times 1/4. So 1 times 1/4 is 1/4. What is 1/4 of $1? 25 cents. So if I buy two eggs, this costs 25 cents. So 2 eggs would be 50 cents. 3 eggs would be 75 cents. 4 eggs, I believe, would just be $1. $1.25, $1.50, 7 eggs for $1.75, 8 eggs for $2, 9 eggs for $2.25, 10 eggs for $2.50, 11 eggs for $2.75, 12 eggs for $3. Plot points in the first quadrant of a coordinate plane. The horizontal axis is labeled number of eggs and the vertical axis is labeled price. But before we do let's look at this. Is the relationship additive or multiplicative? How do you know? What's the relationship between the number of eggs and the price? Are we adding or multiplying? Because here you're adding this way, but it's asking what's the relationship between the number of eggs and price. So is the relationship between, I should have written, between the number of eggs and price. So is the relationship between the number of eggs and price additive or multiplicative? It is multiplicative. How do you know? You have to multiply each number of eggs by 25 cents. Now let's plot them. So they said that the horizontal axis will be labeled number of eggs. Number of eggs. And the side would be labeled price. Price what? Dollars? prices, yeah, dollars. So 0 goes here. Do we want to label 1, 2, 3, 4, 5 all the way here and squunch it up, or should we spread out the information? I don't know about you. I'm going to spread out just a bit. Let's see, 1, 2, 3, 4, 5, 6. So I'm going to do every other block. 1, 2 eggs, 3 eggs, 4 eggs, 5 eggs, 6 eggs, 7 eggs, 8 eggs, 9 eggs, 10 eggs, 11 eggs, and 12 eggs. And a price. 25 cents for this one, 50 cents for this one, 75 cents for this one. So every other one. 1, 2, 1, 2, 1, 2, 1, 2, a dollar, 1, 2, $1.25, 1, 2, $1.50, 1, 2, $1.75, 1, 2, $2, 1, 2, $2.25, 1, 2, $2.50, 1, 2, $2.75, 1, 2, $3, 1, 2, $3.25, 1, 2, $3.50, 1, 2, $3.75. I probably should have stopped earlier, so let's graph it now. 1 egg costs 25 cents. 2 eggs cost 50 cents. 3 eggs cost 75 cents. 4 eggs cost $1. 5 eggs cost $1.25. 6 eggs cost $1.50. 7 eggs cost $1.75. 8 eggs cost $2. 9 eggs cost $2.25. 10 eggs cost $2.50. 11 eggs cost $2.75, and 12 eggs cost $3. Should we connect the dots or not? Is it discrete or continuous is pretty much masking. Should we connect it? Let's think about it. Can you purchase from a carton a half of an egg? No, you can't. Because half an egg is all they're going to leave. Can you purchase a fraction of it? It doesn't make sense. So we do not connect the dot. Because I know you're always used to connecting the dot when you graph it. But in math, sometimes we don't. It's called discrete. Discrete means you're not connecting the dot. So use the graph, make a prediction to find the cost of 14 eggs. So 13, 14. If I make a prediction, it would be $3.50. Create a proportion or rate table to find the cost of 14 eggs at the unit price. So let's create a proportion or rate table. So this is number of eggs. Let's do cost. Cost eggs. 1 egg costs 25 cents. So if I need to find the cost of 14 eggs, what's the relationship between 1 to 14 times 14 times 14? 25 cents times 14, that's where you get the 350. So let's do another one. Cost an egg. What if you have to, so it costs 25 cents for each egg, per egg. What if you had to buy 20 eggs? So the relationship is times 20. What is 20 times 25 cents? 0. 5 times 2 is 10. Placeholder. 2 times 0 is 0. 2 times 2 is 4. Don't forget the decimal point, 2 places. $5 for 20 eggs. So after we've done that activity, this is a activity for those who do finish early. This is a graph. The graph shows the information about the number of sweatshirts sold and the money collected at a fundraiser for school athletic programs. Use the information in the graph to complete the table. 3 sweatshirts cost $60. 5 sweatshirts cost $100. 8 sweatshirts cost $160. Does it make sense to connect the points on a graph? Can you buy a fraction of a sweater? It's either a whole sweater you're buying or, yeah, that's it. It's just a whole sweater. You cannot buy 8.5 sweater. It's either sweater or not. So the answer is, whoops, what happened? Oh, does it make sense to connect the dot? No. Can't buy fractional sweaters. What is the unit rate for the scenario cost per sweatshirt? Let's think. Cost per thing. So, oh, it's right here. One sweatshirt costs $20. I don't know what is wrong with this stupid thing. All right, this is getting so confusing. I'm sorry. Better. So what is it? It's cost, oh goodness gracious, $20 per sweatshirt. Javier says that 7 sweatshirt costs $140. Was he correct? Let's look at the graph to see if his prediction is correct. 7 sweatshirt costs $140. I believe he's going to be correct. Is he correct? Yes. If you look at a table graph, you'll see it. Another way to do it is proportion. Sweatshirt cost. One sweatshirt costs $20. 7 sweatshirts times 7 times 7 scale factor, $140. Fam says that 25 sweatshirt would cost $5,000. Is he correct? Well, let's look at this. What's the relationship between one sweatshirt to 25 sweatshirts times 25? 20 times 25 is $500. That doesn't make sense. And does the order pair 15,300 makes sense for the scenario? That means 15, let's go back to it. 15 sweatshirts for $300. So it'll be somewhere up here. Well, that makes sense. Would that make sense? Let's see. If you buy 15 sweatshirts, what's the relationship between one sweatshirt to 15 sweatshirts times 15? So it's 20 times 15 is 300. So yes, it does make sense. And this is the study of using graphs, rate, unit rate, and prediction.